What if the seeds of our current climate crisis were planted centuries ago, not just decades? Get ready to unravel the forgotten history of climate change, from ancient civilizations to pivotal industrial shifts. This isn't just about melting glaciers. It's about uncovering the surprising origins of our environmental challenges and how they've shaped our world today. Most people think climate history starts with factories and cars, but the Earth's climate story is written in stone, ice, and wood. Scientists called paleoclimatologists act like detectives, studying clues from the distant past. By drilling deep into ancient ice sheets in Antarctica and Greenland, they extract ice cores. These cores contain tiny trapped air bubbles, a pristine sample of Earth's atmosphere from thousands, even hundreds of thousands of years ago. We can literally analyze the air our ancient ancestors breathed. Similarly, every tree ring tells a story. A wide ring means a good year with plenty of rain and sunlight, while a narrow ring points to drought or harsh conditions. By combining data from ice cores, tree rings, and even sediment layers at the bottom of lakes, scientists can reconstruct Earth's climate with astonishing accuracy, long before humans started keeping records. This field, known as paleoclimatology, shows us that Earth's climate has always changed naturally. There have been ice ages and warm periods. We see how ancient civilizations, like the Mayans or the ancestral Puebloans in the American Southwest, thrived during favorable climates, but struggled or even collapsed when faced with prolonged droughts or cooling periods. Their stories are a stark reminder that societies are deeply connected to environmental stability. Understanding these natural cycles is crucial because it gives us a baseline, a way to measure just how dramatically human activity has thrown the system out of balance. The story of human-caused climate change begins much earlier than you might think, not in the 20th century, but in the 19th. In the 1820s, a French mathematician named Joseph Fourier first proposed that Earth's atmosphere acts like a greenhouse, trapping heat and keeping the planet warm enough for life. He didn't know exactly which gases were responsible, but he laid the conceptual groundwork. Then, in the 1850s, an Irish physicist named John Tyndall decided to test it. He built a sophisticated device to measure how different gases absorb heat. He discovered that gases like water vapor and carbon dioxide were incredibly powerful at trapping heat, while the main components of our atmosphere, oxygen and nitrogen, were almost transparent to it. Tyndall essentially identified the key players in the greenhouse effect. But the real bombshell came in 1896. A Swedish scientist, Svante Arrhenius, took it a step further. He was curious about what caused ice ages and wondered if changes in CO2 could be the trigger. He spent months by hand calculating the effect of doubling carbon dioxide in the atmosphere. His conclusion? It would raise global temperatures by about 5 degrees Celsius. It's an astonishingly accurate prediction made over a century ago, with just pen and paper. At the time, these were mostly academic discussions. Arrhenius even thought a warmer planet might be beneficial, allowing for better crops in northern regions. They couldn't imagine the sheer scale of industrialization that was about to unfold. These were not seen as urgent warnings, but as fascinating scientific curiosities. Fast forward to the mid-20th century. The world was in the midst of the Cold War, and a quiet alarm was beginning to sound. In 1958, a young scientist named Charles David Keeling began a project that would change the world. He set up a monitoring station on top of the Mauna Loa volcano in Hawaii, far from the pollution of major cities, to take daily measurements of atmospheric carbon dioxide. The result was the Keeling curve, one of the most famous graphs in modern science. It showed a clear, undeniable year-on-year increase in CO2. It also captured the Earth's breathing, the seasonal cycle of plants absorbing CO2 in the spring and summer and releasing it in the fall and winter. Interestingly, some of the most important atmospheric research during this time was funded by the military. During the Cold War, the U.S. military was intensely interested in understanding the atmosphere for everything, from spy planes to predicting nuclear fallout. This research, while intended for strategic purposes, unintentionally provided a wealth of data that helped civilian scientists better understand our planet's climate system. By the 1960s and 70s, the evidence was mounting. The first governmental reports started to circulate, and scientists held the first international conferences dedicated to the issue. But it remained largely within the scientific community, a topic of concern for experts, but not yet a part of the public consciousness. The moment the conversation truly shifted from the lab to the living room was in the late 1980s. A brutally hot summer in 1988 in the United States, combined with a NASA scientist's powerful testimony to Congress, suddenly made climate change front-page news. That same year, the United Nations established the Intergovernmental Panel on Climate Change, or IPCC. This wasn't a research body, but an organization designed to synthesize all the available climate science into comprehensive reports, creating a global scientific consensus. The era of climate change as a purely academic topic was over. It was now a major political and public issue. Then, in 2006, Al Gore's documentary, An Inconvenient Truth, brought the Keeling curve and the science of global warming to millions of people around the globe. It transformed complex scientific data into a compelling, accessible narrative. While it had its critics, there's no denying its monumental impact on public awareness. It galvanized a new generation of activists and spurred the growth of environmental movements worldwide. The debate was no longer just about parts per million of CO2. It was about our shared future, our children's future, and our moral responsibility to act. So here we are. Our present predicament was forged in this long, complex past. The warnings from scientists like Arrhenius and Tyndall were not fully appreciated. The clear data from the Keeling curve was, for decades, met with political inaction. Every decade of delay, of missed opportunities, has compounded the problem, making the solutions harder and more expensive. Today, we still face the challenges of organized climate denial, which often exploits the scientific uncertainties of the past to sow doubt about the overwhelming consensus of the present. But looking back at this history isn't about assigning blame. It's about understanding how we got here. Recognizing the long chain of discoveries, warnings, and missed chances is our most powerful tool. It teaches us the importance of listening to science and the profound cost of delay. Understanding our past is the key to finally shaping a sustainable future. Thanks for watching. If you found this journey through history eye-opening, please hit the like button and subscribe for more deep dives into the stories that shape our world. See you next time.